evening guys, Bagus to Mark Leonard C from BSME4. So my answer for number 1, which has a given of which are RK is equal to 9.5, pressure 1 is equal to 100 kilopascal, temperature 1 is equal to 35 degrees Celsius. So you have to make this into a standard form, so you have to add 273 to make it a Kelvin. So 35 plus 273 is equal to 308 Kelvin. Next given is the volume 1, which is 600 cubic meter, and T4 is equal to 800 Kelvin. So the properties of air at room temperature are, so the Cp at room temperature is equal to 1.005 kilojoule per kilogram Kelvin, and the Cv is equal to 0.718 kilojoule per kilogram Kelvin, and the R is equal to 0.287 kilojoule per kilogram Kelvin. So for finding the highest temperature and pressure in the cycle, so A, finding the highest temperature and pressure in the cycle. So first we will use this formula. T2 is equal to T1 V1 over V2 raised to K minus 1, but V1 over V2 is equal to RK. So we will substitute this formula here. So T2 is equal to T1 RK raised to K minus 1. So we just have to substitute all the data from here to here. So T1 is equal to 308 Kelvin times RK 9.5 raised to K, which is equal to 1.4 minus 1. So 308 times 9.5 raised to 1.4 minus 1 is equal to 57.9 Kelvin. So that's the temperature too. And so what we are finding here is the T3. So at point 2, so this is at point 1. At point 2, T3 is equal to T4 multiplied by B4 over V3 raised to K minus 1. So V4 over V3 is also equal to RK. Yes. So we will use this formula, T4 times RK raised to K minus 1. So from this we will substitute this data. So T4 is equal to 800 Kelvin multiplied by RK, which is 9.5 raised to 1.4 minus 1. So 800 times 9.5 raised to 1.4 minus 1 is equal to, so T3 is equal to 1968.60995. So this is the highest temperature in the cycle. So next one is finding the highest pressure. So from P2 V2 over T2 is equal to P1 V1 over T1, we can get the P2 here. So P2 is equal to V1 over V2 multiplied by T2 over T1 times pressure 1. So this V1 over V2 is equal to RK. So since it is equal to RK, we substitute all the data here. So RK 9.5 multiplied by the T2 that we get. T2 is equal to 757.9 Kelvin over T1, which is 308 Kelvin multiplied by 100 kilopascal. So P2 is equal to 9.5 times 757.9 over 308 multiplied by 100 is equal to 2,337.6786 kilopascal. So for finding the P3, we use this formula. P3 V3 over T3 is equal to P2 V2 over T2. So we can derive this formula into this. P3 is equal to T3 over T2 times P2. So we can substitute all the data here, which is T3 is equal to 1968.6995 1968.6995 Kelvin over T2, which is equal to 757.9 multiplied by pressure 2, which is equal to 2,337.6786 kilopascal. So P3 is equal to 1968.6995 over 757.9 times 2,337.6786 is equal to 6,072.2875 kilopascal. So this is the pressure, this is the highest pressure in the cycle. So next one is finding the amount of heat transferred in kilojoule. So we use a B, finding the amount of heat transferred in kilojoule. So first we need to find the value of mass. Mass is equal to P1 V1 over RT1. So pressure 1 is equal to 100 kilopascal. Volume 1 is equal to 0.0006 cubic meter. From this we converted centimeter into meter cube. So over the R, which is 0.287 kilopascal meter cube per kilogram Kelvin, multiplied by the temperature 1, which is 308 Kelvin. So from this we can get the value of mass 100 times 0.006 over 0.287 times 308 is equal to, so the mass is equal to 6.788 times 10 raised to negative 4 kilogram. So for finding the heat, we will use this formula. Q is equal to mCV times T3 minus T2. So mass is equal to 6.788 times 10 raised to negative 4 multiplied by the CV, which is equal to 0.718, and then multiplied by the T3, which is equal to T3 is equal to 1968.6995 minus the T2 is equal to 757.9. So we can get the value of Q 6.788 times 10 raised to negative 4 multiplied by 0.718 times 1968.6995 minus 757.9. So the value of heat is equal to 0.5902 kilojoule. So this is the value of the amount of heat transferred in kilojoule. So next one is finding the thermal efficiency. So at Q out, it is equal to mCV T4 minus T1. So mass is equal to 6.788 times 10 raised to negative 4. CV is equal to 0.718 multiplied by T4, which is 800, minus T1, which is 308 Kelvin. So 6.788 times 10 raised negative 4 multiplied by 0.718 times 800 minus 308 is equal to 0.2398. Q out is equal to 0.2398 kilojoule. So for finding the work, because it will be needed in finding the thermal efficiency, so work is equal to Q in minus Q out. So the Q in is equal to 0.5902 minus Q out 0.2398 kilojoule. So the work is equal to 0.5902 minus 0.2398 is equal to 0.3504 kilojoule. So for finding the efficiency is equal to work net over Q in. So work net is equal to 0.3504 kilojoule over Q in, which is equal to 0.5902. So the answer that we will get from here is 3504 over 0.5902 is equal to 0.5937. So we have to multiply it by 100% to make it a percentage. So the thermal efficiency is equal to 59.37%. So that is the thermal efficiency index cycle. So the last one is finding the mean effective pressure. So the first that we will get here is the V2. So we will use this formula. Mean effective pressure is equal to work over V1 minus V2. So work is equal to 0.3504, and since the formula of V2 is equal to one minus 1 over RK. So that's the formula for V2. So we'll use this to substitute for V2. V1 is 0.0006 cubic meter multiplied by 1 minus 1 over 9.5. So the answer that we will get from here is 0.3504 over 0.0006 times 1 minus 1 over 9.5 is equal to 652. Mean effective pressure is equal to 652.7059 kilopascal. So that is the mean effective pressure, 652.7059.